My name's Matt. I am a real customer. I am a senior site reliability engineer at Instructure. I'm really excited to be able to share with you a part of our story and to highlight some specific S3 patterns and practices that have helped power our growth. Learning has evolved from a strictly on-premise brick and mortar experience to a blended, sometimes even fully online experience. At the same time, learning itself has become a lifelong journey. Whether it's engaging young learners on their mobile devices where they spend a lot of their time, to outcomes-based education, or for helping workers upskill to switch career paths or gain a promotion, truly we are never done learning. And at Instructure, our goal is to support teachers and learners at every stage of this journey with intuitive, robust, reliable software to help those that want to learn engage with those with the knowledge to teach and then to get out of their way. We make the Canvas Learning Management System, or LMS, for kindergarten through university level higher education, as well as the Bridge Employee Development Suite for the corporate space. As a company, we were born in the cloud. We never had an on-premise data center. We were born in the cloud on AWS in 2008. At the time, I think AWS was like 4 services. We used all of those services then, and we use about 60 AWS services now. We launched generally available production just 8 years ago, but since then we've grown to 30 million users in 70 countries. We operate over 10,000 EC2 instances at peak, and we've got a few petabytes stored on S3. Throughout this growth, we've maintained 3 nines of uptime, which we credit to our cloud strategy. It's enabled us to accommodate over 1 million concurrent users and to do so fairly cost effectively. I'm going to drill down into our Canvas environment and give you a sense of our architecture. Like a lot of companies, we have a monolith and then a lot of smaller services. In our case, for both, we have elastic load balancers that sit in front of auto-scaling groups where we have many EC2 instances comprising a layer of stateless compute. In both cases, we have, for stateful backends, PostgreSQL running on EC2, S3 buckets, of course, also DynamoDB, and RDS. We actually have over 100 clusters of the monolith, so each of these clusters is running the same code as the next, and each of our tenants is assigned to one specific multi-tenant cluster. And we have over 50 different of these smaller services, and they're each running different code from the next because they have distinct purposes. We have a variety of mechanisms for intercommunication between these services in the monolith, including synchronous HTTPS APIs, SQS, Kinesis, and of course, S3. Finally, we've got an ecosystem of extract, transform, and load services, ETL services. This is primarily Spark running on EMR. We have some Flink streaming data as well. These are primarily customer-facing analytics, so helping our users understand better how their institutions are using the platform so that they can get the most value out of it. Typically, our EMR clusters are reading in data from S3, processing it, and writing it right back out to S3. We do not run a perpetual HDFS cluster that exists in between runs of the ETLs. S3 is also the durable layer for our Flink states. There's a lot that makes this interesting that's non-technical also, and this stuff doesn't show up well on an architecture diagram. We're a 1,500-person company now. When I started 6 years ago, I was employed maybe number 300, and we broke into this market by throwing away the rule book that said that learning management systems had to be proprietary software that was run on-premise by each institution. We said we're going to open source our product. But then we're going to offer a software as a service, a SaaS experience. It's so excellent, people will gladly pay us to host it for them. Then we're going to reinvest that revenue into the software and use the control and the flexibility that we have because it's SaaS, because we can directly manage the running software to innovate really quickly and try new things. And putting this all together, we can deliver a global, secure, accessible product that's available 99.9% of the time in your choice of 33 languages and dialects. And as we've grown, we haven't wanted to lose that competitive advantage, that thing that has made us different. So we have a lot of teams. We've tried to keep product development teams really small, give them autonomy to choose the right tools for the job. That means those 50 services we talked about earlier are each owned by one of over 40 or so teams. In production, we've got Ruby and Golang and Scala and Python. The list just goes on. It wouldn't all fit on the slide. Each chosen because it was the correct tool for the problem at hand. This is part of our practice of autonomy. Teams get to choose their tools. We're now spread over more than 40 AWS accounts to provide blast radius isolation and, again, enable team autonomy. These factors, the number of services that we have, the number of teams, the number of AWS accounts, they're actually all reasons why S3 shows up so many places in our stack. Let's look at a very specific example, one I work with every day at Instructure of how we use S3. Now, the red arrow here is going to represent what we call shard data dumps. Shard data dumps. So we run the relational database PostgreSQL on EC2. In some regions, we have over 100 clusters running the database. On each cluster, we have hundreds of shards, so those are separate Postgres schemas, each dedicated to one or a few tenants. Postgres makes a fantastic relational database, but there are times when we would prefer to batch process over this data, and in particular, to batch over many shards of data at the same time. And so we dump all of this data to a single S3 bucket per AWS region. So thousands of Postgres schemas, each with dozens and dozens of tables, get dumped to S3. This comes out to be roughly 1 million objects and around 20 terabytes per time we run the dump. We run that dump a couple times a day. We retain several weeks worth of history. We end up with nearly a petabyte in our largest shard data dumps bucket. Do want to note that this isn't our backup strategy for this data. We do use S3 as part of that backup strategy, but this is a method of data interchange that ends up backing quite a few data products and services that we offer. So costs could add up quickly here if we didn't do anything to cull the older data. So to keep costs under control, we use S3 Lifecycle Policies to just expire and delete objects after 28 days. There's no muss, there's no fuss. We have that 28-day history when we need it, and there are times when that's particularly useful. But we don't have to worry about our storage costs growing exponentially over time. Likewise, from a site reliability engineering perspective, we have no operational burden of having to manage some daemon that really does need to work exactly correctly because its job is to delete data, and you really only want it to delete exactly the correct data. We use lifecycle policies on this bucket to expire incomplete multi-part uploads. And though it's not applicable to this particular bucket, there are many buckets in Instructure where we do tier things down with lifecycle policies to standard infrequent access and to S3 Glacier. So on the read side, the prefix structure of this bucket was designed so that we could retrieve only the data that we needed on each run of one of these batch processes. Most of our data services don't need all 20 terabytes out of every dump because not all of our customers use all of our offerings. The internal bucket structure allows for the retrieval of just one shard's worth of data, and by specifying the timestamp associated with a particular run of the dump job, you can retrieve just a subset of the data also. So when I talk about multiple services reading this data, that was never the plan. Shard data dumps was created to enable a single data export service a few years ago so that we could provide a customer with a dump of all of their data. But life has found a way, and we now have a dozen or so internal services that consume the same S3 bucket to provide a variety of user experiences. And the thing that I find so remarkable is that the service that writes the data out to this bucket has had to change nearly nothing over that time and throughout that process. What we've accomplished is a fan-out and cross-account pattern that allows us to share this data with all the services that need it. In our model, when a team first wishes to access this bucket, they're probably doing so from their own AWS account. That is not the same account where the bucket is located. And so in order to make that work, the first and only thing that we need to do on the side of the service that is publishing the data is to add that team's AWS account to that bucket policy. At that point, the team can stand up additional services in the future that consume from this bucket by granting the resources in their AWS account read permissions to this particular bucket. This is really powerful because it allows teams that want to solve interesting data problems, sometimes using new technologies, to do so really quickly. We don't get caught up on transport layer issues or credential exchange. There's no lobbing of tickets over to the team that owns the shard data dump service. S3 is agnostic to the specific stack that's consuming it. Again, that allows teams to be autonomous, which is very important to us. To quote one of our principal engineers, I know that if something is in S3, it will cost me effectively 0 implementation time to consume it. It would be completely amiss if I didn't hit on the durability that S3 provides, because it really is the most fundamental thing that it gives us. It opens the door for everything else. At Instructure, our software is a source of truth for course content, for student submissions, for grades. We take data durability incredibly seriously. For those buckets that contain critical data, we turn on object versioning. We make sure that previous versions of objects are not cleaned up automatically for an extended period of time. This makes object deletes and mutations effectively reversible. For our most critical data, we also use S3 cross-region replication to make sure that data is present in multiple geographically distinct AWS regions. We found that with S3, so long as we do our part, the data is still going to be there where we need it to be, and S3 provides features, including these, that make it a lot easier to do our part. So to summarize, S3 is absolutely a critical part of our infrastructure. We use it all day, every day for a variety of purposes. Shard data dumps is just one example of how S3 is a fundamental part of our success. It doesn't just provide for us an excellent technical solution to some pretty weighty problems. It also enables a powerful organizational structure that has helped us to scale our entire enterprise and accomplish our mission of helping people grow from the first day of school to the last day of work. Thank you.